Okay, yesterday we already talking about the computer system. Okay, and two things will be uh, learning in this system. They're talking about the memory, and you understand in the memory you can get a RAM, random access memory, and the ROM. That means read only memory. The ROM will be contain the data for operating system. That means when either you turn off your computer, the data in the ROM cannot be erased. However, the RAM, that means the random access memory. That means while you're working on your computer, everything you do, they must be stored in the RAM memory. So when you turn it off, all of the memory in the RAM will be empty. Okay? And that's what we already done yesterday. Only thing is make sure you understand okay, that means you're looking into a very simple memory. Each one here, they call a word, word zero, word one, or they can call address zero, or they can call location zero in the memory. That's what we're talking about the RAM. Okay, the RAM you're able to writing data into the memory, and also you can reading data out of the memory. Okay, and basically we already said memory make up either by a flip-flop or a capacitor. Okay, a magnetic. We don't care magnetic. We care about flip-flop capacitor. If they're using the flip-flop to build the memory, and you understand on each cell here, just a one flip-flop inside, just a D flip-flop, for example. And D flip-flop, they get only one Q. If they get a one mean Q equal to one. If you get a zero, Q equals zero. Okay, and so on. So when you're writing the data to the memory, so the new data write into the same location. What happened is they erase whatever inside that location to get a new data. Okay, you can write into it, and also you can reading data from any location of the memory. And for the flip-flop, when the Q equal to 1, and they will be equal to 1 if the power is still on. Okay? However, when the power turn off, everything will be 0. Flip-flop, they already reset it. Only difference between the capacitor memory, that means they call a dynamic memory. Basically, they need the safety. Make sure the capacitor charging or discharging and not leaking. Okay? And that's why when you buy the computer, they can ask you want add RAM. That means static RAM or add DRAM, dynamic RAM. Add RAM means using the flip-flop. DRAM they using capacitor. Okay? So that's very, very simple for the memory. So when you want to test the memory, only thing is you write data into each address, each location. Then later on, you read them out. You compare to what you read them out with what you wrote it in. If they're the same, that means part. If they differ, that means some wrong. So now I can tell you, when you test the memory, okay, you write data into first location, 0, 1, 0, 1. Then you write data in the second location, 1, 0, 1, 0. And now if you write to another one, they have to be 0, 1, 0, 1. Why we have to do that way? I can tell you, inside this location here, it's to cell they next each other. So you never want to writing 1, 1. The reason is if they tie together and the test cannot be failed. They must be either 1, 0, 1, then have to be 1, 0. Okay? And also from this cell here going down here, they will be next each other. So the data you load it into the memory and must be the same thing. You cannot loading all 1 or all 0. So inside they tie together, you never know. Okay? And also the way for testing memory, you loading all of the data to each location. Then now you start reading 1 by 1. We're not testing it writing into the location 0 and reading from location 0 right away. No, that's not the way. Okay? And that one we already telling you yesterday. Okay? And that already done on this part right here. Only make sure you understand they say 1K. 1K in the memory represent for the 1024 word. And some people can asking for how many bits per word. It's hard to say. You cannot say 4 bit. You cannot say 8 bit or 16 bit. Basically, depend on the computer. Okay. That one we already done yesterday. Okay, so basically, this is just a timing. We don't care. You are not designer. Okay. That means how long take the cycle for reading, how long for take the cycle for writing into the memory. Okay. And like, to say, you can see it right here, they say write. Okay, that means the data have to be valid for how long, okay, before you write. And then you can say on that one, EEPROM. EEPROM, that means EEPROM or EEPROM. That normally they contain operating system. While you're working on the computer like we're doing right now, the data coming out from EEPROM or EEPROM, we cannot writing any data into this IC. However, if you want to change something in the computer, you restart, press F2 or DEL. They go to the setup. That will be allowed to write data into that EEPROM. Okay. And normally, if you see on that one here, they get this power here, 25 volt. Turn it on. So now they allow you to write new data into that EEPROM. Okay, so we don't have any more. Now I go into the other one, memory review. Try to understand, and we'll be talking to you about, okay, let me copy one by one. Okay, number one. How many address lines required to select the specified memory location? So the first one, you get 4096. Okay, that will be address.
12.
4096 address or location or worse, then require how many the wire
12.
address? How many?
12.
12. Okay, he said 12. You need 12 wire. Okay, how do we know that will be 12? I already telling you. You have to using the formula joule power n equal 4096. Then tell me what n equal.
12.
They have to be 12. 2 to the power of 12. 4096. So that's why they need 12. Okay? And how about 8192?
13.
13.
Now you get it. 8192. So you get the wire here, address will be 13. 2 to the power 13 equal 91, 81, 92. Okay, any question? In order to telling how many wire for your address, the thing that you need to know when you're looking into the wire, also you know inside how many watt they get. Okay, I given you again. If I get this one here, that's a RAM. 512 watt. Okay. Then how many address? Wire.
9.
Yeah, that's a very good. Nice. Now you understand. Okay, any question on this one? Okay, let's say number 2. Why I copy they not show up? Okay, anyway. How many memory locations do we do the following RAM configuration? 2K by 4. 2K by 4. How many locations? How many words?
2048.
Yeah. You understand 2K mean 2 times 1, 0, 24. Okay? 2 times 1, 0, 24. You get 2048. 2048 location or 2048 address or 2048 words. Okay? So they want to know how many memory location. The answer will be 2048 location. Yeah.
Mr. Pham, and what does it mean, the number 4 accompanying?
For bit
Okay, okay.
or location.
Thank you.
Okay. And number B, 2048 by 1. And now they given you a word, a location. The answer will be 2048 location. And each location will be only 1 bit. Okay?
So the 4 and the 1 tell you how many bits per word.
Right, exactly.
Thank you, sir.
Okay, number 3. A certain memory has capacity 16K by 32. how many watts does it store? If you know how many watts, I just telling you, you just do 16 times 1024. Whatever you get.
Is it 16,384?
Yeah, whatever, you just multiply it. Okay? So that's, they say how many watts, then that's what you can get total watt. 16 times 1024. What is the number of bits per watt?
32.
Perfect. The answer will be 32. How many memory cells does it contain?
And a cell is 1 bit.
Exactly. That means
500
they want the capacity.
It's 524,288.
Okay? That means you take the total number of watts, right? Times 32. So what the number you get?
524,288.
Right? Okay, number 4. Draw a logic diagram for 16K by 1 RAM with active low enable. Normally, in any, inside the computer, normally they get enable. The thing is they tie the same data bus or address bus. Okay? That means you get the same IC on the same bus. They tie output, input together. So basically, data only allow one IC can send any data out in the bus. Otherwise, you get a problem. So now they say draw logic diagram for 16K by 1 RAM active low. So the first thing what you need to do, you have to tell how many address, okay, how many location, and how many input output for that memory. So the first thing you can get, this will be address here. How many wires? You should know 16K, right? Times 1024.
14 wires.
Yes, 14.
Okay, so you can get number 14 wire. Correct. How many input, output, divide? I/O. How many?
That's the same as the number 1 there?
1. That means you get the total watts, but each watt will be 1 bit. And the last one, active low gypsy light. That will be, they can call it gypsy light, or they can call enable. Active low, that means a 0 here allow you to writing data into the memory, okay? And a 0 here allow data can coming out of the memory, okay? If you get a 1, that means disable. That means any address or input output cannot go inside the memory. They just isolate it. Look like no memory in that system. That will be enable or gypsy light. Okay, number 5. Now the logic simple for 256x4 RAM. Common I/O pin. Also active low.
Hey, Mr. Fan,
Yeah,
real quickly before you go into number 5, is it proper to say that the 0 is enable and the 1 is disable?
right.
Okay, because I heard you say enable for 1. So you meant 0 for enable and 1 for disable.
All right.
Okay, thank you.
The thing is, you see the bubble, right?
Right.
0 means allow data can coming in or out that memory.
That means enable.
Right.
And then 1 means it cannot go in or disable.
Right. If 1, that means the data cannot get inside the RAM, the memory.
Right.
Matter what.
And that's the same as saying that you're turning the chip on with a 0 or you're turning it off with a 1, right?
Yeah, if you want to,
For this function.
yeah, if you want the memory to working, then gypsy light have to be 0.
Yes, sir.
If you
Yeah, I see what you mean, Adam. 0 on, 1 off.
Right, right.
okay, the
If
thing
Mr. Pham agrees.
that the way they design the memory is, if you disable and they have to get a, what they call a tri-state high impedance. Look like that IC not there. So they're not loading any current on the bus. You understand, inside the computer, they have to get a data bus, address bus. They share, all of the IC will be shared. So only one data can be go on the bus. Okay? Cannot two. I given you the example. Very simple thing. You get inverter. Two inverter. You can tie input together, that be okay. But you cannot tie output together. Why? The thing is, if you get the input here, zero, then output will be 1. If you get a 1 here, output will be 0. When they tie together, what logic you think?
1,
When the output is tied together?
Yeah,
They will clash.
1.
Yeah. Yeah, it's a high impedance.
no. They don't have any impedance on the inverter.
It just won't work because you one of them wants to throw a 1 out there, the other one wants to throw a 0 out there, so it's like they're fighting against each other.
I agree. But what my question is, what logic at the output?
You're going to see 1 if they are tied together. Yeah.
Now, I tell you. 1 means 5 volt. Right?
right.
You'll be in that no man's land between. There'll be no logic at all.
No, that's not right. I said 1 mean 5 volt. How about
Okay.
0?
0 is like ground.
No
volts.
votes.
0 volts.
0 is ground.
0 is ground. So it would probably act like ground.
Yeah,
Okay,
it's ground.
so you're going to see 0.
Yeah.
I see now.
If you connect 5 volt to 0, what do you think you get?
You get
Zero,
zero.
okay,
Zero.
Okay,
no.
that makes sense.
Okay.
Makes sense.
Yeah. 0. So that's why I just bring it up to telling you one thing. Input you can tie together. However, output never. Okay? Never tie together. So
It's almost like pre and clear. They can be 1 at the same time, but they can never be 0 at the same time.
yeah, but that's not allowed anyway.
Right, yeah, right.
So that's why you can see in your computer 64-bit, 32-bit for the data, for example. And that means on off the memory, on off the circuitry need the data. They will be on time to the 32 wire. However, the data only get one output at a time. You cannot get two output going at the same time. They're messing up. So that's why they all the time they need the enable, or they need the chip select to control, make sure only one output can be going to the data bus. Okay? So now draw the logic 256 by 4 RAM. That's not easy for you, right? You tell me how many address here. How
8.
many input, output here.
That's 2 to the 8th.
That will be 8, right? Is it
Yep.
256. And that have to be,
4.
that means
4 bits per word.
4 bit per word. Correct. Okay. Now, I'm telling you, how do we get the memory?
Mr. Fahmy, in the last example, the 4 bits per word is the same that 4 wires.
4 wire for input, output.
Yeah, 4 input output wires is the same.
Yeah, 4 wire.
Okay, thank you.
Now I pick a simple one. Okay, RAM. Okay, 1K by 4. Okay, so now what you think what we can get? First thing you can get address.
Chain address, 4 input output wire.
How many wire?
4 chain address, 4 input output wires.
10, right?
Yes, chain address,
And data here.
4.
Perfect. Now 4. And now you can see the RAM. They can get the line for read, write. That will be read and write. Okay? That means depending on you want to read or you want to write. And then last line here. Okay, they can go a CS, chip select, active load. So now, how many locations in this memory? How many address? How many look?
1024.
Perfect. Okay. So you understand you get a 1024 location. Okay. And now if you're talking about the decimal, okay, they go from what location to what location in decimal.
From 0 to 1023.
Perfect. Yeah, you look like good now, man. Okay.
I had been studying.
In decimal, okay, location. Start from 0 to 123. 0 to 1023 total will be 1024 location. The thing is, in the decimal, you start from 0, okay? So, if we have to do the test for this memory, how many tests do you think we're supposed to test?
Sorry, what was the question, Mr. Pham?
How many tests do we need to complete testing for this memory? Okay, so you have
20,004.
Do you need one test for each location?
No, you just need to test each wire.
now you can see, I can show you. They get 4 bits, right?
Yes.
So that address 0. And that will be 1. And that will be 2. And 3. And 1, 0, 20.
Or okay, 20, but
Hey,
yeah,
Mr.
but 23, 24 in total.
Shouldn't zero be even and 1 be odd?
Can you tell me again?
Should 0 be even and 1 be odd?
Be odd.
Yeah, in other words, 1, 3, 5, 7, 9, that's odd.
Right.
0, 2, 4, 6, 8 is even.
Right.
You put odd where 0 is at.
0 mean even.
Right. You need to change that. Make it look
This is
even.
address.
The first,
Oh, okay. He wrote address there. I see. Okay. I
okay.
thought he wrote odd.
So basically, you can get the location from 0 to 1023. Each location, they get a 4 bit, right?
Right.
What happened now is the way they testing, they can write 14, 0 to 41, or 0, 1, 0, 1. Okay? And the next one, the data have to be opposite. Will be 1, 0,
0.
1, 0. And they repeat it again for all 124 locations. Okay?
Hey, Mr. Pham, a question here.
Yeah.
You know what? When you did that, I noticed you the first one you got 0, 1, 0, 1, and the second one you got 1, 0, 1. Are you also checking the bits for highs and lows to see if it worked?
Okay, basically, when you try to do, you write the data to location 0, and the data will be 0, 1, 0, 1. Then you write the data to a next location. The data will be 1, 0, 1, 0.
Mm.
Then now if you do a next one, they will be the same, the first one.
Right.
Okay? That means they cannot be the same. First location 0, 1, 0, 1, the next location cannot be the same.
Okay.
Cannot be opposite. And you have to repeat that for 1024 words.
Okay.
So the way testing is, first thing you write on of the 0, 1, 0, 1 to the even location. Zero, 1, 0, 1. Even mean 0, 2, 4, 6, and so on. Then you write data to the odd location. 1, 0, 1, 0. Odd will be 1, 3, 5, and so on. Okay? After you completely loading the data into the memory, now you can reading data from even, and the data supposed to be 0, 1, 0, 1. Then you can reading data from odd location, and the data supposed to be 1, 0, 1, 0. So my question is, how many tests for even?
Well, if you got 1024, I guess you got it, because you got half of them even and half of them odd. So if you, that 1024 or 1023, you got to divide it in half.
Okay.
So that's like 512.
Okay. So basically you get 1024 locations. Then
So
now
512.
you divide 2, right?
Right.
2, what,
412.
512, right?
Yes.
Yeah.
So you get a 512 test. And also you get another one will be 512 test. You get that?
Right.
Yeah. And then, Mr. Van, and then it is not necessary to switch and test the 0101 on the odd and 1010 on the even location to test everything. It's okay.
Yeah, perfect. We're not done yet.
Okay. Okay.
And now the even you test for the data 0101. Then you have to test again for data 1010, right?
Mhm.
Yep.
And the other out location to do the same thing. So that will be telling you, you get another 512 and another 512. So 512 times 4,
2048.
2048 test.
Is it 2,000 or 4,000?
2000, right? Let's see,
Yeah.
2000, sorry.
$2,048.
2048 test. And now you can see we never try to run. Not enough time. Okay?
That's why you like to use the for loop, right?
Yeah. But I'm talking about we did verify your lab by running the program with the hardware, right?
Correct.
And so and in the next, we cannot. The thing is, take too long. Maybe 2 hours, maybe 1 hour for one program.
But Mr. Pham, like I was saying, but the for loop is better because if you was to write out each and every one of these tests, you would be writing out 2,048 tests individually, right?
No way.
So you could start on Friday night when class ends and finish Sunday.
But the thing is that's a very simple only. You just using the for loop. See? For, j equal 0, j left, then equal 512. Then you write data into the memory. So just a few lines, they can do 512 tests.
Start on Friday, finish on Sunday, ready for Monday.
Okay. So without the software here, no way you can test the memory. If you go to the college, they will be using by hand, manual. They set a switch to location and they set a switch to data and set read or write, okay, and set the chip select. So they just test only one field location. They cannot test things like the company do it. So you can see that the software are very, very important. Okay. And I'm working on the D lab number 9. And we'll be talking about how do writing the data into the memory. In order to write to the data to the memory, how many steps do we need? For example, you have to apply address, location, which location. Then you have to set the read and write input to be 0. That means the data will be go in the memory. Then the next will be applied what data you want. You say 0101. So you have to apply the data 0101 to the data line. However, you already set it up, address, data, read and write. However, data are not coming into the memory yet until the chip select normally high until they go in low. Okay, so when they go in low here, our data will be go into that location. After you get a negative pulse on a chip select, now they bring it up to logic 1. That means after you write data into it, and now they disable. In and out cannot connect together. The reason they have to do that way is guarantee if you keep this chip select 0 on the time, what happened? That means when you change the address or you change the data, they keep going inside. So that's messing up. So that's why when you want to change the different location, you change the different data here, okay? Then the chip select must be at the logic 1. so the data cannot come inside until you already set it up ready. Then pull the chip select load. Data can go into that location. So the program basically very, very long. However, the coding very, very short. 512 tests, you just like few lines, not much. Then they can do 512. Okay? And you can see this is a very, very simple thing when you're working on the memory lab.
It's too easy.
The one, the lab 8, that's a little more complicated, but the memory will be very simple. And that normally you working in a company, guarantee you have to deal with the memory test. Okay, any question? Will be more detailed when we go into the DLab number 9. We'll be telling you how many steps need to do to write data into the memory. How many steps need to do in order to reading out of data from the memory. So make sure everyone understand. I want you to do the lab number 8. Don't do any lab from 7 byte, okay? For now, you still owe me. However,
I have a question, Mr. Pham.
go ahead.
I know like from the way you're explaining right now, it's kind of like, to me, I'm kind of like having a hard time understand, like what is the best way to practice? Like, should I just read the handout or like go to online, like YouTube or something, or Google?
No, nothing. Only thing is on the lab number 8, I already given you the Excel, right?
Yeah.
I want that to be part, right?
Uh-huh.
Okay, after you part, now we try to converting into the test program. So I already telling you on the test number 1 what we're doing, what we are going to do. And you follow that. And now if you not quite understand, you can get in Zoom to me. I help you to understand how to doing your coding.
Okay, I'll be on Zoom with you for sure.
Yeah, anytime. Okay.
Thank
Try
you.
to understand that why we doing that. For example, for the test, you get a test number, you get a test title, and now you need to apply the input to the circuitry. Then after you apply the input, and now you need to reading out and verify go or no go, pass or fail. And the test will be just the same test for every time you do it. There's just a very different input data or output data. The test program is not create new technique to writing the program. No, they just copy paste, and you can change what you need to change, and the change will be what you need to apply and what you need to verify. Okay, you get any question, anything you can feel you get lost.
I have a question.
Yeah, just a minute. You have to start over. Yeah, go ahead.
Sorry, Mr. Pham. So my question is about chip select. So you said when it is 1, it is not possible to read or write data, right?
What do you mean? Read or
Chip-
write data?
Chip select, when it is high, I can't write or read data from this memory.
Exactly.
When is zero, I can read or write data.
Right.
Thank you.
And chip select is the same thing as enable.
Right. Either one. Either way they want. Some schematic they're using enable.
Okay, thank
Some
you.
schematic they're using chip select. We try to both. So when you're working on a company, you get the schematic, then you understand they will be the same thing. Okay, anything else?
I can just say to everyone else in the class from personal experience, don't be afraid to Zoom with Mr. Pham. He won't get mad at you. He's very helpful and you'll understand a lot faster.
Yeah, the thing is Adam, right?
Yeah.
Yes, sir. Yes, sir.
He been on Zoom with me, you
A
know,
lot.
a lot. But you know, when you get a better understanding, that make me happy. Okay. The thing is that the purpose I still working. I still running this program.
All right, Mr. Pham, we're gonna have to make you happy.
That's what I want all of the students in TechJo. I
That's right.
want to help you to get the technician job. Okay, that's a very important. Try to get a technician job. Understand what you're doing. Okay. The thing is when you know how to do what to do, I believe 8 hours in the company not enough time for you to do your job. So that's a really, really happy. We don't want to go to the company and try to waiting until the time we get out. No, that it take a long time. All my life working, I never pay attention on how many hours I've been in working in the company. They want the job to be done. And if you cannot get it done, sooner or later, you can be leaving company. I want you guys to be a real technician. And some people, some students, I recommend keep going. Someday you'll be engineering. I can guarantee that. You can understand what I'm trying to teach you. No problem when you go to the university. Okay, any more question? Anything else? Otherwise,
Mr. Pham.
yeah, otherwise we will see you guys tomorrow.
All right, thank you.
Tomorrow.
Okay,
Thank you so much, Mr. Pham.
Thank you, Mr. Pham.
Thank you.
you are welcome.